Here's a 1974 MGB Roadster. This car was used as an electric vehicle back in the mid to late 90s, running on 120 volts, 12 volt batteries, 10 batteries in series. The previous owner decided to convert it over to 6 volt batteries at 96 volts to get a longer range, approximately double the range. This car should probably get about a 50 to 60 mile range with moderate driving on 6 volt batteries. On 12 volts it was getting at about 25 mile range. This is the Curtis PB6 potentiometer, which will essentially be the throttle control for the vehicle. It's hooked up to the original gas pedal behind the firewall. Here is the 9-inch ADC DC series motor, which replaces the internal combustion engine. It has a custom plate that's made out of aluminum, and it hooks up to the original clutch, which is hooked up to the original transmission. For city driving, we should be able to keep it in second gear because of the extremely powerful low-end torque of this motor. And for freeway driving, we can always put it into third or fourth to get the higher speeds. This is the DC to DC converter, which takes the 96 volts from the traction battery bank and converts it to 12 volt, charges the 12 volt accessory battery, which is behind the driver's seat, which will also control the speed controller. The main contactor, which is right here, has 12 volt coils and will be operated by the accessory 12 volt system. The controller used in this vehicle is a Curtis 1221B, which is mounted on its side here. Very popular in the 90s, still a good controller, but of course superseded by some of the more advanced modern controllers, particularly the Zilla, which is currently not in production. I've installed 2 AC fans, which you might be able to see here below where the original radiator cap is, and these will go on when plugged into the AC charger charging system, and these fans will disperse any hydrogen gas which accumulates during the charging process, what they call gassing of lead acid batteries. If you're using sealed batteries, that will not be an issue, or lithium-ion batteries do not have that problem. But in this case, the 120 volt fan operates from the current that is plugged in when you're charging, so you don't actually draw from any of the vehicle's current, so it's a very efficient way to go. There's also a special relay hooked up right over here, which will shut off the ignition system while the battery's charging, so that if you forget to unplug the battery charger before you want to drive away, it will not yank your battery connections and charging connections loose. In the back, we have room for an additional 9 batteries, utilizing this custom battery tray that was welded in by the previous owner. Very nicely done. It's made to accommodate 9 6 volt Trojan T105s or similar. There's the other AC motor, a fan, which will disperse the hydrogen gas, and the K&W Technologies BC20 Charger, which will charge up to 96 volts, plus there's an add-on booster that can charge up to 120 volts. And here's our main breaker, which is accessible from the driver's seat, so if there's an emergency I can flip the switch and hopefully save the car and or lives. We will hopefully be getting this thing running in the next few days after we acquire some batteries. Until then, signing off and stay tuned.